Good day, learners. This is Easy Engineering. This time, we're going to talk about motion in two dimensions, projectile motion. In previous video, we learned the concept of a straight line motion, a car moving a horizontal motion along a straight path, and a stone falling vertically from a third floor building to the ground. But now, how about if an object experiences moving along horizontally at the same time vertically? This kind of motion is called projectile motion. In this video, we will learn the concept of a projectile motion. Suppose you are firing a cannon at some angle. The cannonball will follow a parabolic path during its flight before it reaches the ground. We will try to understand the movement of the cannonball. First is its velocity. Initially, the cannonball has initial velocity. This initial velocity can be resolved into its x direction as and y direction as. This means that the cannonball is moving upward while moving to the right. When the cannonball moves upward, the velocity in x direction is constant or the same as the value of, while the velocity along y direction is approaching to 0. When the velocity along y direction is equal to 0, the cannonball is in its maximum height from the ground. The cannonball continues its parabolic path. During its flight, the cannonball experiences a motion going downward while going to the right. This time, the velocity along x direction is still constant, but the velocity along y direction is approaching to the value same as the initial velocity along y direction, but in negative value to indicate that it is going downward until the ball reaches the ground and the velocity is 0. To sum up everything, the velocity along x direction is constant and the velocity along y direction is changing with respect to its position. Initially, the velocity along y direction is when the cannonball reaches the maximum height, the velocity along y direction becomes 0, and the velocity of a cannonball before it reaches the ground is equal to the initial velocity along y direction, but in negative value. This time, let us look at the acceleration. There is no other acceleration governing to this kind of motion, but only the acceleration due to gravity, which is equal to 9.8 meters per second squared. This acceleration is pointing downward and is constant during the cannonball's flight. Lastly, for distances, there are only two distances which we should give attention. These are the maximum height, when the cannonball's velocity along y direction is 0, and the distance traveled of the cannonball during its flight. Before we end, let me leave you with this trivia. Did you know that in projectile motion, to have a maximum distance travel of an object, it should be fired at 45-degree angle? That is all for now. I hope you learned something today. Once again, this is Easy Engineering.